This is a problem that was asked about. It was one that we did in class for an example for our final exam review, and someone asked about the roots on the imaginary axis, so we're just going to go over that. Now, if you remember from class, we went through and we constructed the routh array. Remember to do that. We are going to look at the denominator of this equation, and we're going to fill out the first two rows from those coefficients. So if we do that, we're going to have 1, -7, and then -18. And for the second row, we'll have 1, -7, and then -18. Obviously, these are going to create a row of zeros. So this next row would be 0 with 0. So here's our row of zeros. Okay. So then we have to go through and get our polynomial. We'll take the derivative and all of that. So if we do that, our P of S is going to be s to the fourth minus 7s squared minus 18. Take the derivative of that, you get 4s cubed minus 14s. So this is going to become 4. This becomes -14. And then keep going down the array and construct it like we normally would. So you get -3.5 with -18, -34.57, and finally -18. Alright, so now we're to the point the array is constructed. Now we need to look at the first column, and we're going to look for our sign changes. Now remember, we're going to break it up into two sections. We want to go to the row above the row of zeros. This is our auxiliary polynomial row. So we're going to have a section from here down, and then we're going to have a section from that line up. Okay, so we're starting at the S4 row. So from this row down, we're going to have 4 of the roots. Okay, so 4 of the roots are going to be determined by looking at the sign changes from these parts right here. Okay, so if we look, we're going positive to positive, so that's not a sign change. And then we're going positive to negative, so that's one sign change. And then the rest are negative. So we have one sign change. Okay. Now that means we have one root on the right hand side. Now remember, when we have this auxiliary polynomial, we have to have symmetry. So if we have 1 on the right hand side, wherever it is, that means for symmetry we have to have 1 on the left hand side. Okay, so now we know the location of 2 of the poles. Alright, so we have 1 on the right hand side, that gives us 1 on the left hand side. Now if you look, we only had the one sign change. So we still have 2 poles, we don't know where they are. If we don't have a sign change, they can't be on the right, which means they can't be on the left. So that means they have to be on the imaginary axis. Right? So now we've got that. So basically, if you don't have a sign change, you're going to have poles on the imaginary axis. Okay? So that's all we can do for this section here, for the s to the fourth down. Now we need to look for that sign change for that section above. So if we look up in here, we're looking at this section right here. We're going positive to positive. So there is no sign change, so that tells us we have 1 on the left hand side. Right, so now we have 1 on the left hand side. So that gives us a total of 1 on the right hand side, 2 on the left hand side, and then 2 on the imaginary axis. Alright, so hopefully that kind of clears that up. But let's do another problem. This was a homework problem. So let's go down to this one. This was number 19 out of your book. Alright, so here is the transfer function that we had. Again, we're always going to focus on this denominator. So if we pull out our values and create our array, we're going to have, let's switch back to green, we're going to have 1, and then 10, and then 169, and then we'll have 3, 30, and then 507. So now let's keep going. If we do the determinants and everything, we're going to end up with a row of zeros right here. So row of zeros, that means we have to find the auxiliary polynomial just like we did before. So here we'll have 3s to the fourth plus 30s squared plus 507. Take the derivative of that, That gives us 12s cubed plus 60s. So now we get rid of this 0, this becomes 12, this 0 becomes 60. And then continue with the calculations, you get 15, and then 507, and then negative 345.6, and then 507. Alright, so we have this row of zeros, so again that means we need to check to see if we have poles on the imaginary axis. And you can only have poles on the imaginary axis if we have a row of zeros. Alright, so we find our row of zeros, we look up above that, because this is the row where we get our auxiliary polynomial. So now our section, we're going to have a section from here to here, and then we'll have this section from here to here. Alright, so we got our two sections, so let's do them separately. So for this bottom section here, remember everything S4 and below deals with the auxiliary polynomial. So let's go through and count the sign changes. So here we have positive to positive, and then we have positive to positive, and now we got positive to negative, so there's one there, and we have negative to positive, so there's one there. So that's two sign changes. Alright, that means that we have 2 on the right hand side. So now if we draw that out, let's just say they're there. Now we have to have symmetry for this. Okay, so that means for this one we have to have 1 on the left hand side, and then for this one we have to have 1 on the left hand side. Now if you notice, we have s to the 4th. That means we have 4 poles that we're dealing with. And if you notice, right here, we've already got the 4 poles. Okay, so we have 2 on the right hand side, and then we have the corresponding 2 on the left hand side. So that means there are 0 on the imaginary axis. Okay, so now this takes care of this bottom section. Now we need to look for the rows above the auxiliary polynomial. So we just have this one row, the one between s to the 5th and s to the 4th. There is no sign change, so that means there's 1 on the left hand side for that one. So our totals then, we're going to have 2 on the right hand side and then 3 on the left hand side. Right? And that gives us a total of 5 poles, which that's what we should have because we have a 5th order equation. Alright, so I hope that helps a little bit. Just remember on these with the row of zeros, you need to have a sign change in order to have poles that are not on the imaginary axis. Otherwise, they will lie on the imaginary axis. Okay, good luck.